Hey, Michael, how's it going?
Can you hear me? Hi, Joe.
Yeah, I could hear you.
Okay.
Yeah. You eating?
Yeah.
I'm trying now. Nah, I'm eating this. Oh, not that. I'm eating cereal.
Jeez. Where you at in your room?
Yeah, no, this is another room in our house.
Oh.
Yeah, but right now I was looking at the computer,
Mm.
doing the work and all that.
Yeah. I'm signing in right now.
I've been started. Which one are you on?
Uh, Hold on. I think I'm on 7.2 or something like that.
Oh yeah, I'm in 7.2 still.
Yeah, yesterday. Or is it 7.3 or something like that? I don't know. Dude.
Hey guys, I just have the notes sitting up here as
Doing
people are logging
7.2.
in.
I still couldn't finish.
Time to check those, okay? While we wait for everybody to get logged in.
Oh, hey, Miss Paham.
Hello.
How you doing?
I'm fine.
Oh, we miss you, Miss Paham.
I'm sure you do.
Yeah, we do, Miss.
But just if you did your notes, check them, and if you didn't do your notes, then be looking at these so you can check them, fill them in while we're waiting for everybody to get logged in.
Okay.
Yes, well.
Because we still got a couple others to wait on.
I cannot see that.
Pedro, where's your glasses at?
I still don't get them. I get
Yep.
them. I get them probably this week or next week.
Mm.
Yeah. Hey, I got 2020, bro.
No way.
Yeah.
No way.
So let's see. All right. All right, who else do we still need? I see Michael. I see a blank screen for Pedro. I see Mia. I see Karnaya. I see Javier. So we
I'm
lost.
drinking my coffee, that's why.
You did what?
I'm drinking my coffee.
And
I want to show myself drinking coffee right now.
really? All right, so we got Monica, Pedro. All right. 1, 2. So we're just missing Kaya, right? I think. Put on there. Yeah. All right. All right, is everybody working on writing these down if you hadn't already?
Yes, ma'am.
All right, they're in your folder that I got sent home, the orange folder in that middle section.
I lost it, miss.
I'm not surprised. You better find it.
I'm trying to find it.
Uh-huh. Okay, so just. All right, get started.
You can get some paper out.
We'll come back to that later if you need it. Everybody enjoy their extra week of spring break? Yeah, I see heads going up and down. Except for Pedro.
I'm enjoying this, man. I like working every day.
Aw, okay. So
Bye, miss. I have to go. I have to work.
no,
See you.
you have to work in geometry. All right. Now, what we're gonna do is we're gonna try to make do where I can still use the board a little bit because it's kind of hard in math not to write on the board. I'm using that one sideboard. That way it doesn't glare quite as bad with the lights as the board did. I'm trying to write around the few glare spots that you can see behind there to do the best I can so y'all can actually see it. Okay. But I know it's been 2 weeks, but we're working on circles still. We had started circles before spring break. Remember you had a quiz that last day, which most of you did halfway decent on that quiz. Okay, on section 8.1.2. So you had that quiz, but now we're going to be working on section 8.3. Okay, and with section 8.3, these are the problems we're going to work on. So we're only trying to get through 23. Okay, we're going to try to work through that as best we can together. Okay, so I will unmute you if I expect you to answer me when I call on you for something. So you need to be paying attention to where we're at. Okay, I need to be able to see that you're actually there and listening and following along. We are on pages 365 and 366. That is what we're working on with our geometry. Okay, so that's where we're at. So everybody should have their big geometry book, hopefully, because they were all sent home with all the other stuff that was sent home if you didn't already have it at home. So you find your geometry book and get open to that page, and then we'll start talking about arc measure and arc length, because those are two different things. So is everybody getting their book? Yes or no? We got their book, we're ready. And like I said, sometimes, well, I'll unmute everybody, but most of the time I'll leave you muted just because of background noise, people coming in and out, or if you have dogs, whatever, because, you know, they get loud. Very good, Javier. I see your book. Thank you. So he hasn't changed any in the 2 weeks. All right, so we're starting on page 365. This picture is for like the first several problems. So I've got it drawn up here, even though I hate drawing circles on the board. I did try to draw it on there. Okay, if you all do need to log in to ask a question or anything, you can unmute yourself as of right now, unless you start trying to talk over me, and then I'll do it. What, Pedro?
Which page?
365 and 366.
Okay.
See it? It says it on the board behind my head. Okay. All right. So on these, I just taken my book. We're talking about different types of arcs and stuff. And this was on your notes that some of you obviously didn't try to start filling out until I had the thing up there when you got in today. So at the end of class, I'll leave it up there again for you to try to get some more of it copied in, filled in if you need to. Okay, but we're talking about circles. Remember, from the center to the circle is a radius. All the way across through the center was the diameter. Those are the two main ones that you need. And then the curved part on the circle is an arc, and that's what we're focused on today, are the arcs and their measurements. Okay, now when you are talking about an arc, like the arc from B to C, its measurement is equal to its central angle, the angle that makes that arc, that separates that section of the pie off of the circle. Okay, so that's what you can kind of think of it. Think of it as like a pie or pizza that cuts off that slice of the circle. That measurement's going to be the same. So if this is 50, then this arc here is going to be 50 degrees. If this is 20, then the angle inside is going to be 20. So that's what we're doing on this first part. We're going to be talking about those measurements and just also naming them. If it's a smaller arc, less than halfway around, that's a minor. If it goes over halfway around the circle, like from B all the way around to A, that would be a major arc. If it's exactly half the circle, called a semicircle. Okay, so those are your three main types. So looking at number 1, it says name each described arc in circle O, and then identify the arc as minor, major, or as semicircle. Those are the 3 definitions I just said. So we're on the book, page right here. We're getting ready to answer these first ones. Okay, so on number 1, it says the endpoints are A and D, and it contains point F. So here's A and D, and it contains point F. So it's going from here to here. Is that a major or a minor arc? Is it all the way around? Is it more than halfway, less than halfway? Y'all can unmute and answer.
Minor arc.
Okay, everybody say minor? Okay, good. So it's a minor arc. So you just name it with the 2 letters if it's a minor arc. If it's a minor arc, you just have to use the 2 endpoints. You don't have to use another point to know which one you're talking about. So your answer is just AD and minor. So that's all we're doing on this first part. On number 2, it says endpoints E and C containing point B. E and C containing point B. So that's not going this direction, that's going around this way. It's going from E all the way around through B to C. So that one's going to be the opposite and be a
Major.
arc, and it's going to take 3 letters to name it. When you're naming the major arc, you use the 3 letters to show which side you're going around the circle. Okay, so it said E and C through point B, so those are the 3 letters you use. Your symbol for the arc is just a little curved, like rainbow looking arc above the letters. So pretty easy? Yeah, these are pretty easy, right? Good, I'm glad it's an easier section when we first have to start doing this from home. Number 3 says endpoints A and C containing B. A and C containing B. So if you look, A and C are the endpoints of a diameter of the circle. So that's where it splits it in half. So that's going to be a semicircle. Semicircle because it's where it cuts the circle in half. Okay.
Okay.
Pretty easy?
Yes, ma'am.
Okay, good. Number 4. Endpoints B and E containing A. B and E containing A. So if you look at this, is this going to be a diameter again?
Yes. Yes,
So
ma'am.
it's a diameter 2. So it's going to be another semicircle.
Yep.
Okay, so you use the 3 letters. You put what type it is. Pedro, where are you hiding? I told you you can't hide. Number 5. So then Javier goes and hides with him. All right, number 5. Oh, that's not number. Why am I numbering these? Y'all just don't say nothing, do you? A, this is B, this is C. E, E. Sorry, they're parts of number 1. So on part E, it says endpoints D and E containing F. Here's D and E, but it contains F. So that means it goes from D all the way around the circle through F to point E. So if it's going all the way around, that's going to be what?
Major.
A major arc. What, Pedro? I saw you had your hand up. What do you want?
Mm-hmm.
Okay. All right. Part F. This is the last one of those. Okay. On part F, it says endpoints C and F containing E. So here's C and F, but it contains E, so it's going around this way. So is that major or minor?
Minor.
Minor. And so it goes just from C to F. Okay. If it's minor, you only have to use 2 letters. If it's the semicircle or the major arc, you have to use 3 so you can tell which direction, which way it's traveling around the circle. Okay. So that part pretty easy.
Yes, ma'am.
Next part is the actual angle measures or arc measures. So this is number 2. What do we got now? 2, 3, 4, 5, 6, and 7. 4, 5, 6. We'll get through that part, and then we'll move on. All right. So for those. Number 2 says the measure of arc BD. So what you need to do is you look, here's point B, here's point D. So remember the arc is equal to the measure of its central angle. So its central angle is going to be these 2 together. So 50 plus 45 is
95.
95 degrees. So arc BD equals 95. And that's how you do. Okay. So the next one is AB. AB from here to here. Now, do I know what this is yet?
No.
I don't know what this is yet, but I know this divides the circle in half, right? An entire circle is 360 degrees. Half the circle is 180. So remember, this is straight, so they have to add to equal 180. If this is 50, to find out this part, I do 180 minus 50 and get 130. So this angle, this arc's going to be 130 degrees. All right. Next one, number 4, arc AD. So from A all the way around to D. Okay, that's this bottom half. Remember, we just said this cut AC cuts it in half. So if this part's 45, this whole other part between A and D would be 180 minus 45. So it's going to be what?
35.
135.
Yeah, 135.
135.
Forgot the 100.
Okay, it's 135. Next one, ED. E to D. Okay. To find this part, we just found out from A to D was 135, correct?
Mm-hmm.
We know this part's 30. We know this part's 20. So if I take 135 minus 30 plus 20, which is 50, I will get?
You'll get 85.
85. Y'all agree with him?
Yes, ma'am.
Okay.
Here's my calculator.
Number 6, measure mark A and B. So from A through point D all the way around to B. So this whole bottom half we know is 180. This part up here is 50. 180 plus 50. And get what? I have more than one person who can.
240, maybe?
230.
Oh, it's close.
230 degrees. Okay?
Oops.
All right.
Miss Pelham, there's a bunch of people cutting grass right now.
There's
So it's
what?
there's people cutting my grass right now, so it's kind of loud.
Okay. All right. Alrighty. We'll mute everybody for a minute. Okay. So looking at number 7. Number 7 says BAD. So our BAD goes from here all the way around to here. Okay. So from BAD goes from here all the way around to here. So it's all of the circle except this part. Okay. Well, this part we said we knew was 95 degrees. So an entire circle we said was 360. So you take 360 minus 95 to get your answer. And you'll get 265 degrees. So to find the arc measure, I'm going to speak this a little closer. To find the arc measure, you have to look at what's there on the circle. Sometimes you have to add, sometimes you have to subtract, but it's equal to it's a central angle. The angle that's there in the middle is equal to the arc. But you got to remember a whole circle is 360 degrees. You got to remember half a circle is 180 degrees. Okay? All right. Now, for the next part, it says find the value of each variable where L represents the arc length. On your notes, there was a formula for arc length. The arc length is equal to the angle divided by 360 times the circumference, which I think it just had C, but the formula for circumference is 2 times pi times the radius. But it's the angle measure over 360 times the circumference. Okay? So what we're going to do is it gives you those things on the picture. So we just plug them into the formula. That's all we got to do. So on number 9, to find my arc length, my angle measure was 75. I put it over 360, and then I'm going to multiply that by 2 times pi times the radius, which was 8 inches. So all I want you to work on doing is getting them plugged into the formula, because I know half of you are not going to have a calculator at home, but you can do calculator a lot of times like on your phone, whatever, but this way at least get them all set up first, that you know how to plug them into the formula. The angle measure goes above 360, and then you have 2 times pi times the radius. So that's what we're doing on 9 through 14. So on number 10, my arc length is equal to, the angle was 134 over 360 times 2 times pi times the radius, which was 12. So all I want you to work on doing is getting those set up. Okay. All we're doing right now is we're plugging them in to the formula. Okay. So let's look at number 11. To find my arc length. Now on this one, it didn't give you the angle measure. It gave you the arc length. So on number 11, we're working backwards. So our L is given to us. Well, I'll still write the formula. Our L is given to us, so we have theta over 360 times 2 times pi times radius. That's our formula. But my arc length was given to me. It's the, what is that, 35 pi? Ooh.
Yeah.
That 35 pi over 4. Sorry, I had to have the light off for this side because I'm trying to cut the glare and then I'll get it. So equals to, we're looking for the angle over 360, 2 times pi times the radius, which was 15. So we're still doing the same formula, it's just you're working backwards. But right now, I'm just worried about you getting them plugged in. Okay, then we'll go back and talk about solving them. On number 12, on it, this time you're looking for the radius. It gave you the R. So what we're gonna do is you're gonna have your arc length, 3 pi over 2, is equal to the angle over 360, which the angle was 45 over 360 times 2 times pi times R. And then we'd work backwards to solve for the pi. For the R. 13. Again, you're looking for R. It gave you 6 pi over 15. Is that a 6? Yeah. No? What is that? Is that a 6 or an 8?
8 pi.
8. 8 pi over 16, 15?
15.
15 equals, then the angles, 48. 48 over 360 times 2 times pi. Okay. And then the last one of those, number 14,
Yep.
says it gives you the arc length of the other, not the one you're looking for. So we're really going to have to work backwards on that one. We're going to have to take 10 pi, that's the arc length of the big part, is equal to, I don't know, it's not the angle I want, so I take 360 minus the angle over 360, and then 2 times pi times 6. Okay. Like I said, we'll go back later and talk about actually working these out, but I wanted at least everybody to get them plugged in and written down how to plug them into the formula. Okay. Now, for 15 and 16, it says use the figure where circle P is congruent to circle Q for exercises 15, 16, and 17. So on 15, it says if segment AB is congruent to segment CD, AB and CD, if you look at the picture, are 2 chords. They're 2 segments whose endpoints are on the circle. So the chords are congruent. And then it says the measure of angle APB is 80 degrees. Then the measure of angle CQD will also be 80 degrees. Because if the chords are congruent, the angles are congruent. That's one of the formulas, the theorems that you had to fill in on your notes. If the chords are congruent, the angles are congruent. Okay, so then the next one, for 16, it gives you the two angles are congruent. So then it says AB is equal to 12. So what's CD going to equal? Same thing. If the two angles are congruent, then the two chords are going to be congruent. It works both ways. And those are theorems that you had where you were supposed to fill in on your notes. Okay. Now the next one. If APB is 75 degrees and CQD is 75 degrees, what's true about AB and CD? What did I just say? They have to be what?
Congruent.
Congruent. If the angles are congruent, then the two chords are congruent.
Yep.
He says, yep. Okay, they are congruent. Okay, and there's the theorem, the way it words it, because congruent central angles intercept congruent chords. That's how they word it. Okay, congruent central angles intercept congruent chords. Okay. Now, number 18. How many linear feet of gutter are required over a bay window if its arc measure is 150 degrees and the radius is 8 feet? So basically what it's asking you is for arc length. So we're still using the same formula that we used over here, the arc length. The length is equal to the angle over 360. So it said it was 150 degrees.
Yeah.
Yeah. So 150 over 360 times 2 times pi times the radius, which was 8 feet. And then all you do is you work it out. Now, I know you all, like I said, with the calculator stuff, but you should still be able to simplify this for the most part, because here you can reduce this fraction because you know you can cancel those out, the zeros on the end. And then a number that goes into both 15 and 36 is 3. So I can divide them both by 3. And I get 5 over 12. And then I can take 2 times 8, which is
16.
pi. Now, is there something I can cancel out from the 12 and the 16?
Yes.
Yes, 4 goes into both of those. So I have 5 over 3, and then 16 divided by 4 is 4 pi. And then what's 5 times 4?
20.
20. You have 20 pi over 3, and then whatever you did was, I think it was feet. But that's how you can still go back and simplify them and work them out, even if you don't have a calculator. It's basically just looking for factors you can cancel and then multiply them straight across. So that was all of them on page 365. Everybody get those down.
Yes, ma'am.
I have to write it
Put
down.
all those down. All right. Let's go to the next part. It's on page 366. Everybody turn their page. It says complete the table by finding the missing value for each arc. So you've got your radius and your arc measure and the arc length. So are we still using that same formula over and over again? Yes, we're still using the same formula. So on 19, we're just gonna set them up and then we're gonna go back where y'all can work on filling them out. So on 19, what you're gonna have is you're looking for arc length. So you have the arc measure over 360 times 2 times pi times the radius, which was 3. And like I said, you can work on canceling stuff out to simplify these. First, the 50 over 360, you can cancel like that. So I've got 5 over 36. Now, there's not really anything else I can cancel out with the 5 over 36. 2 times 3 is 6. So I've got 5 over 36 times 6 pi. The 6 will cancel, though, going this way. 6 goes into itself, 6 goes into 36. So 5 times 1 is 5 pi. 6 times nothing on the bottom is 6. So that's what we're doing on 19, 20, 21, except sometimes it's giving you the arc length and the radius, and you're finding the angle. Sometimes it's giving you the angle and the radius, you're finding arc length, but you're still using the same formula. So let's look at 20. On 20, it says you're looking for the radius. So your arc length goes first, which is 8 pi over 9, which equals the angle, 16 over 360 times 2 times pi times the radius is what we're looking for. Okay, and then you got to simplify what you can. So when you go to do that, over here, what goes into both 16 and 36? The light's not on there.
4.
Okay, 4 goes into both of them. So over here, I have 8 pi over 9 still. 16 divided by 4 is 4. 360 divided by 4 is 90. And then 2 times pi times r is 2 times pi times r. You just round next to each other. Now, what else can I simplify?
The 4 and the 2.
No, this is on. You can top and bottom is what you can simplify.
Oh.
So, is there something else that goes into 490?
2.
So divide by 2. Divide by 2. Okay. Over here, I have 2 over 45 times 2 pi r. Okay. Now I can multiply this straight across. I have 8/9 pi equals, what's 2 times 2?
4.
4 pi r over 45. Now you're trying to get r by itself. So to get the r by itself, I need to get rid of the rest of the fraction. To get rid of the rest of the fraction, you multiply by it flipped over, which is called its reciprocal. So I'm going to multiply by 45 over 4 pi and 45 over 4 pi. Because when I do that, I'm going to have stuff going to cancel. This cancels, this cancels, this cancels. I've got r. Okay. Over here, pi cancels. 4 goes into 8 2 times. 9 goes into 45
5.
5 times. 5 times 2 is 10. My radius is 10. So we use the same formula over and over on almost all these problems. It's just we have to do a little bit more work to get the variable by itself that we're looking for. Okay, we're almost done because I told y'all we're just going through 23. We're gonna make it. So 21. All right. So on 21, we are looking for the angle measure. So we have the arc measure 7 pi over 2. The arc length. We have the angle over 360 times 2 times pi times the radius, which was 7. So this is what we're working on this one, okay? So to do this, You're still going to simplify this side first that you can. So I have 7 pi over 2 equals theta over 360 times 2 times 7 is 14 pi. So basically what you could do is instead of writing this as a separate fraction, you can write it all together. Okay? You can put the 14 pi and the theta all right there next to each other, like what we had over here when we did the 2 pi r with the 2. Now, we're trying to get theta by itself, so are we going to do the same thing that we did over here? We're going to multiply by the reciprocal. You're going to flip it over. So you're going to multiply by 360 over 14 pi. So when you do that, the pi part cancels. You know that all of this cancels on this side. 7 goes into 14 how many times?
Twice.
Twice. 2 goes into 360. 180. So I have 180 over 2, but can I divide that?
Yeah.
So I get, okay. So is everybody at least getting these down that we're going over? Yes, no?
Yes.
I'm trying to go through that. I know these are, it's kind of harder to do math this way, but we're trying to make best way we can, okay? All right, so we're almost done. We got 22 and 23. They're still using our same formula again, okay? On 22, it says find the arc length and the sector's perimeter of a 55-degree arc of a circle with a radius of 2. So we start off finding our arc length. Let's get back this way. Our arc length, remember, is this formula. So the angle measure was 55 over 360 times 2 times pi times the radius, which it said was 2 inches. So this is what we're going to do. We're going to simplify this like we've been doing the others. Okay, 2 times 2 is
4.
4.
So I've got 4 pi here. And then can I simplify 55 and 360? Is there something that goes into both of them?
5.
5 goes into both of them. So 55 divided by 5 is 11. 360 divided by 5. Y'all slowed down on that one. What happened?
72.
72. Okay.
72.
Yeah, Peter, I ain't talking to you because you're trying to hide the whole time. All right, so I got 11 over 72, and that's multiplied by the 4 pi. Now, can I cancel something into the 4 and the 72? Yes.
Maybe?
Yes.
Yeah.
They're both even, so we know at least what goes into them.
2.
2.
2, but should 4 actually go into both of them? Anyway, should 4 go into 72?
Sorry, miss.
How many times? How many times can 4 go into 72?
I don't even know.
Let's see. Okay.
18.
You say,
Yeah,
okay.
18.
All right. I'm going to make y'all do old school division down here. Okay. So 4 goes in 18, you said 18 times. So I've got 11 pi over 18. Okay. That is your arc length. Okay. I can't handle that. Let's get them on. All right, 23. Or do we finish 22? 22 also asks for the perimeter, right? Okay, to find the perimeter, what you do is you take the arc length and then you add it to the two radius. Because remember, when you have these, I told you it's like a piece of a pie being cut out. So the perimeter is the distance around the outside. So it's going to be the radius, and then this arc length that we just found added together. That's going to be your perimeter. So I'm going to take the perimeter is equal to 11 pi over 18 plus the radius and the radius. So it said the radius was how long? 2? Is that right? I'm looking.
2 inches.
Yeah. So 2 times 2 is
4.
4. So I just add that together, and that's going to be my answer. And most of the time, what they do for that is because you got the fraction, you got the thing that's not, is they'll leave it as 11 pi over 18 plus 4 inches. They leave it that way. They don't try to add them together. Okay, so you just leave it like that. Okay. Let's get through 23 real quick. We got like a minute. All right, 23 says find the arc length and the sector's area of an 80-degree arc of a circle with a radius of 18. So arc length equals the the arcs measure 80 over 360 times 2 times pi times the radius on this one, which was 15. So you multiply all that together. So 80 over 360, can we simplify that?
Yeah.
Those cancel first, and then for 8 and 36, I know 4 goes into them. So I divide by 4. 8 divided by 4 is 2. 36 divided by 4 is 9. And then I multiply that by 2 times 15 is 30 pi. Now, can I simplify something with the 9 and the 30?
Yeah.
3 goes into both of those. So I have 2 times 10 is 20 pi over 3. So that is the perimeter, the arc length. Then the other part it asked for, I think on this one, was the area of the sector, I believe. I'm trying to find it again. Yeah, the area of the sector. So remember, area, you do what with the radius to find the area of a circle? Area of a circle is what? Pi times the radius squared, right? Area of a circle is pi times the radius squared. So what we're going to do is you're going to take this to find my area. I'm going to take that times the radius, which was 15, squared. So you're going to multiply those together. So 15, well, I left out my pi. Pi times the radius squared. I left out my pi. So when you go to do that, 15 squared is 225.
Yep.
And then you have the 20 with that, right? 20 times the 3. Okay, so I'm going to have 20 times 3 with that. So 20 times that, and then you're going to divide it by 3. Okay, so 2 times that would be 450, right? It's got an extra 0.
Yes, ma'am.
And then we're going to divide it by 3.
Wow.
Yep.
Big number.
Yes, it's a big number. Okay. And then that's your area. Now, what we need to do is we need to remember when we're doing this that we need to try not to have a whole lot of distractions in the background. Okay? We need to make sure everybody's got their note folder, that you're keeping up with your note folder, that you're actually trying to fill those in. Okay? Start a class tomorrow. I'll have the note folder up there again for you all to be able to look at them and finish filling in some more. You should have pretty well hopefully had the first 2 sections. Most of that stuff that we did before spring break, but I put it on there again because I didn't know if y'all would still have them or not. So I had those on there, and then we'll start with the section 8.3 and 8.4. We'll work on 8.4 tomorrow, and then we'll go from there. Now, when we are doing these, it's more polite if you don't try to hide yourself from everybody the whole time. So I know that you're not just have it on and then you're not even in the room.
Pedro.
Yeah, man, I'm right here, dude. I'm not even hiding.
Anyway, so you guys need to not do that because that looks like a hide. Okay, I don't get to hide. I don't get to hide. So we need to make sure that we try to log in as close to right at 11 as we can. We can get through it, okay? And then we'll go on from there. Now, is everybody's login stuff all working? For the most part, you're not having any issues with that?
No.
Everybody's good logging in?
No.
No. You were the first one on. What are you talking about? Okay. So everybody should be good logging in.
Miss, my phone's dying.
Well, that's sad. You'll have to go charge it because you got another class after lunch, don't you?
No.
All done. You all are done except for your FLVS stuff, right?
Yeah.
Yeah.
As far as logging in for Zoom at lunch. So see how easy, 4 days a week till lunch.
Yeah, but I already have a headache.
Hey, I'm hungry. Okay, I gotta go.
Yeah, I'm going to go cook chicken right now.
This is no different from any other day when you were here because were always like, when do we go to lunch? I'm hungry. So that hasn't changed any, even though you've been home. It's just your parents probably are like frightened.
Is Mr. Pelham at your house, Miss?
Huh?
Is Mr. Pelham at your house?
No, he's here.
I was going to go by your house to eat.
No. All right. So, anyway, everybody knows what's going on with this. Okay. Now, what I'm going to do is if Monica needs to ask me anything for chemistry, I'm going to let her stay on. So if she needs to ask me that instead of her having a separate ID code for that, because she's the only one in there. And then otherwise, for the rest of you, I'm going to try to set up a time like in the afternoons where if you need extra help, just like an open meeting, like for tutoring, since we can't do tutoring, that you all could log in and ask questions one-on-one if you need to. Okay?
That is my teacher, dude.
So you all be good. We'll see you tomorrow. Monica, if you want to stay on so we can check your chemistry stuff, if you have any questions on that. Then otherwise, everybody else will see you at 11 tomorrow. Okay? Hi, work on your notes. Ooh, they flew out. All right. Are you doing okay?
Yes, ma'am.
Okay.
Yes.